Hi my friends, today we model this part. You see all the aspects. This is the drawing. You have to observe that here is an interesting contour. We'll use it with all that dimensions. But we'll start with this hub with a diameter of 50, length of 35. We'll place the center point right here, yes, and this point. This part is number 27 from my collection of 100 mechanical parts. New empty document. Take a look of this workbench and select CAD, not Blender, because we create mechanical parts. New sketch, this plane, and we draw some lines. This is the hub with the length of 35. And with a diameter of 50. 50 divided by 2. Revolve. The axis is Y. Okay. Now we have this hub, yes? And we want to create the external contour of this feature, but we choose half of it, yes, not all the shape. We have dimensions radius 10, 144, 70 here, and this distance of 24 from this face, which contains the center point. Let's create this, and the angle of 30 degrees is to be mentioned. New sketch, the same plane. Then we create a polyline starting from somewhere here, going to the left, MMM. Then we want to be horizontal, MM, horizontal, and we place manually this tangency. But where is the horizontal? Here is the horizontal. Dimensions, this is 144 divided by 2. This is 70 divided by 2. This angle is half of 30. 30 divided by 2. This radius is 10. And this is placed at a distance of 40 divided by 2, this distance is 24. Good. We have a fully constrained sketch. This is true, but we have to add some other polyline, horizontal, getting down. I want to be parallel with the other, but I cannot apply this. MMM to here, then MM to create a horizontal. We apply tangency, do not forget. Here we place on the same vertical. No, we make parallel these two, and we draw a small line here. This line, trim of this end line. Other dimensions, 4 millimeters is the thickness. This is also 4 millimeters. This is radius 10 minus 4. We have green, fully constrained. Now we apply mirror, my friends. Mirror of all these lines. By using this tool, symmetry, about this axis. You see? We have 5 degrees of freedom. Let's try to solve them. I move this here, and I move. You see, this is not connected with this. I place coincident between these 2 points. This point and this line. Good. These are present. You see, 1, 2. We try to move other entities, and we place here the angle of 30. Three degrees of freedom. Let me see what about this. To be sure, we can draw a horizontal from this point to this line. Horizontal is this mark. Then to place coincident this point with this line. Now you see we have other problem with this distance. Firstly, we make this construction, and then we place 40 between these 2 points. One degree of freedom is still free. We can ignore it. Now we see this connection between the hub and this feature. Dimensions 5 millimeters here, and this 10 millimeters from this end. We project this line and we draw a line between this point, any point, to here, and vertical and going to the right here. The other line is from here to up, once again vertical. I apply view inside and I place on the same horizontal these 2 points and one of them with this line. I draw a closing line here, and now I place dimensions. 5 millimeters is this, and 10 is the other. Now we have to eliminate these entities. I eliminate this arc because we have this corner. Then I trim this line. Okay, close this and we apply revolve, but this line is a problem. Let me edit this by making this line as construction line. Revolve the axis Y and you see the result. Okay. We continue with this fillets, radius 3, radius 3, radius 3. We select this edge, then we keep pressed the Control key and we select this one and also this one. Fillet, radius 1, 2, 3. You see 3. You rotate the wheel of the mouse and you obtain that kind of values. Okay, now we have to add these features to the disk. You see here all the necessary dimensions. New sketch, the same plane, and we make visible inside. We project some lines. This one, and this one. We draw a polyline starting from here to the left, up, left, up, left, down, sloped down, and we go to this line. Then we place parallel. These two are parallel, these two are parallel, and also this with this. The angle here is 135. This 135. All these are 4 millimeters thickness. 4. This is 4. Again 4 millimeters. And the last also 4 millimeters. Diameters, this is half of 225. Then this this is 182 divided by 2. This distance to this vertical is 48. This is 48. Then this is 41. Another dimension, and now we see fully constrained sketch. Close and revolve about y-axis. Wire is not closed. You see here? Well, we'll make something special now. Control Z, and we select the sketch and we apply sketch, validate sketch, and we go to highlight trouble zone vertices, and we see something here. This is not closed. Yes, this is the problem. Okay, close, double click on the sketch and create a line to connect these two points. Close, and now we can apply revolve with the y-axis. Okay, there is a hole of 30 here and we want to apply it. Face, new sketch, circle, any diameter, close, hole, 30, and through all. Okay, next are these 3 equidistant ribs. Dimensions 30 degrees, 2 millimeters here, and connecting with the neighbor features. New sketch on the same plane. We want to see inside. I project this face, also this, and we have limits. Now I draw a line starting from somewhere here, going to the vertical line, going back and connect with the point. You see now what is here. This point must be aligned on this vertical. The angle is 30 degrees. 30. Then I have here a point. I want to have here a point so that I project this arc, and now I have that point. I want to place the dimension of 2 millimeters here. To place a dimension, I place a point here. Then I place on the same horizontal this point with this point. I place a point on this line. I make it aligned with this point, and I place that dimension of 2 millimeters from this point to this point, 2. Now we have here a distance between the two because this is a curved face, a cylindrical face. Since we have fully constrained, we can apply extrude. Extrude symmetrical with a thickness of 5. Okay. What is here is this line, the end of that construction. Good. We multiply this rib around in 3 instances. I select this and I select the polar pattern. What is to be placed? This pad. The axis is Y. And now we apply 3, not 2 ribs. You see them here. Okay. You see here the thickness of the ribs. Then we also see this Keyway 8 millimeters with 20 from the center. We select this face. We create a sketch, a rectangle. These 2 points, 1, 2, and this axis must be symmetrical. Then dimensions are 8 for this and 20 for the other. Close. Pocket all the way through the part. Okay. Then we have to place these blades. There are 15 blades with a thickness of 5 millimeters and a distance of 32.5 from this button point. This means that we'll place an arc with a center at 30. We have to place a datum plane here at a distance of 70 minus 48 minus 4 if we start from this face. Let's do this. We select this face, we apply datum plane and the distance in the direction Z, 70 minus 48 minus 2. Okay, we use this datum plane for a new sketch. Then we draw a polyline, horizontal, MMM. Then we go somewhere here. We make horizontal this line. We place this center aligned horizontal with the other, with a center point. Then we hide the datum plane because we want to project this circle, and we draw an arc with the center. This arc starts from here and go to that line. Trim. Good. Then we make equal this arc with this circle. They are with the same radius. Dimensions. This is 5 and this is 32.5 minus 2.5. We have a fully constrained sketch. Close, and now we apply pad or extrude by using not dimension, not to last, not to first, not up to face, not to dimensions, but up to shape. What shape is automatically selected. You see, it doesn't go outside. This is placed on this face. Okay. Now we have to multiply this feature. I select it. I select polar pattern and the axis is Y, and not 2 features but 17 features. Okay, very good. That's all for today. Thanks for watching. Bye bye.